Welcome to lesson number 3. We're going to look at addition and subtraction of rational expressions. In this video, I'm just going to do a couple of the examples for each class example, and probably not even a couple. I'll probably just do example B for all of them, just because those are kind of the ones that are middle to, kind of the middle range or tier 2 type question. When you're adding and subtracting rational numbers, it's gonna be identical. The process is identical, and it is the same process as what you would have seen in grade 9, grade 8, grade 9, grade 10, when you're just working with rational numbers like 5, 6 minus 1/4. And so if you're working with something, what we got to identify is the lowest common denominator. And so what number is the lowest common denominator for 6 and 4 if I want to subtract these? You have to express them in equivalent rational numbers with the lowest common denominator and the denominator as the denominator, and then you also need to determine at the end if you can simplify into lowest terms. So let's look at this first example: 5, 6 minus 1/4. So if I'm working with 5, 6, and 1/4, I know that they have a lowest common denominator of 12. So 6 goes into 12, and 4 also goes into 12. And in order to multiply these both into 12, I'd have to multiply the top and the bottom by 3 on this side, and the top and the bottom by 2 on this side. When I do that, I'm going to end up getting 10 over 12 minus 3 over 12. Now that I have a denominator that is equivalent on both sides, both these terms, now I can subtract. And so 10 minus 3 is 7 over 12. And since 7 over 12 doesn't reduce anymore, that is what I'm going to leave it as. So keeping this in mind, just this process of using the lowest common denominator and multiplying in order to get equivalent denominators and then simplifying, we're going to do the same thing but with these rational expressions. So again, what we're looking at is the lowest common denominator in order to simplify. So in this case, 3 and 6, or even in this case, 4, 5, and 10, the lowest common denominator would be 20. And if 20 is my lowest common denominator, then I'm going to have to multiply my numerators by the same factor that I would on my denominators. Well, let's look at this example. If I have 3a minus 1 divided by 3 plus 4a plus 5 divided by 6, then I know that 3 goes into 6. I know that goes into 6 2 times. And so I'm going to multiply both my numerator and my denominator by 2, which is going to leave me with 2 times 3a minus 1. And this side I don't have to multiply at all because my denominator is already 6, 4a plus 5. But remember that I'm multiplying my denominator, which 2 and 3 is 6, and this remains the same. Now that I have a common denominator, I can simplify. So 2 times 3 is 6a, distribute the 2, minus 2, plus 4a plus 5. Now all we need to do is gather our like terms, and these are all going to be over 6. So 6a plus 4a, we would have 10a. Negative 2 and positive 5 would leave me with positive 3 over 6. And if I don't have any other factors within these terms that I can pull out, then I'm just going to leave as is. And in this case, I can't simplify anymore, so I'm just going to leave as is. So on this side, I'm going to have a lowest common denominator of 24, in which case I would have to multiply this by 3, and I'd have to multiply this side by 8. So if I get this started, 3 times 8y minus 3 over 24 minus 8 times 2y plus 1 over 24. In simplifying this, I'm going to end up with 24y minus 9 over 24 minus 16y negative 8. Negative 8 because of this negative sign in front over 24. Once I simplify, 24 minus 16y, and we can carry that over, but it doesn't really matter. 24 minus 16y, we're going to get 8y. Negative 9 minus 8, we're going to get negative 17 over 24 as a final answer. Alright, so with these examples, notice how it is basically the same process. Well, it is the same process that you use. However, there's that extra step of gathering your like terms with your rational expressions. Alright, let's look at this next example. And between these two, let's look at class example 3a. So 7x plus 3 divided by 2 plus 3x minus 3 over 8. If I look at the common denominator between 2, 3, and 8, my common denominator is 8. And notice how I have 3x right here. And it's always good to keep in mind that when I have a term 3x without a denominator, the denominator is 1. And so what I need to do to multiply, or to get this into 8, on this side I'll have to multiply by 4, and these ones I'll have to multiply by 8. So I'm going to be left with 4 times 7x plus 3 plus 8 times 3x minus, put that in brackets, x minus 3, and 4 times 2 is 8, 8 times 1 is 8, and then 8 is 8. And so these are all going to be over 8. I'm going to distribute my 4 into my brackets and do the same thing across this expression. 24x minus x minus 3 over 8, and then I'm going to gather my like terms. 28 and 24 is 52, minus x is 51x. And then one thing I forgot to do was I forgot to distribute this negative sign into these brackets here, so that would make it negative x and positive 3. So that's going to leave me with positive 15 here. So in the step earlier, I forgot to distribute that negative sign in. And that will all be over 8. Alright, in this next example, I'm gonna do this one over here just because it might be the most intimidating because it's the longest, but the actual process is not going to be different. The only difference is where we're indicating non-permissible values. So the values that x or whatever variable we're working with cannot be equal to. Now in all these cases, we already are working with a common denominator. And so all we got to do is begin by simplifying the expression. So right away, I know that my restrictions or my non-permissible values are going to be x cannot equal negative 3, as indicated by x plus 3 and x plus 3. But I can already simplify this. So 4x plus 10 minus 2x plus 4 all over x plus 3. And so brackets here because I'm going to have to distribute that negative sign in because I'm subtracting each of these terms. So 4x and negative 2x. And actually, before I even simplify this, I'm going to distribute that, take it out of the brackets, and then simplify. So 4x plus 10 negative 2x, and then if I distribute that negative sign in, negative 4 over x plus 3. When I simplify 4x and subtract 2x is 2x, 10 minus 4, negative 6 over x plus 3. Okay, now this is going to leave me somewhere where I can, and that's x plus 6, 2x plus 6. Now if you notice that this is something that I can simplify even further because I can pull the factor out of the top, out of the numerator. So if I divide the top by 2, I can pull out 2 out of 2x would just be x, and 2 out of 6 would be 3. Alright, now I can cancel my factors, and my final simplified rational expression is going to equal 2, with the non-permissible value of x cannot equal 3. Alright, with this next example, I'm just going to do example C. Actually, no, let's do example D in this case. Alright, so 2a squared. Now, this is a different scenario. We're working with different monomial denominators. Right, so this is 2a squared and minus 5a, or a plus 7 divided by 2a squared minus 3 over 5a. When you're in a scenario like this, our common denominator is going to be a combination of these two. So 2a squared and 5a squared. Well, 5a can get into an a squared if I multiply it by a factor of a, but I'm also going to have to think about what 2 and 5 are going to. They're both going to have a lowest common denominator of 10. And so I want to see how I'm going to get them into 10. I know that with 2a squared I can multiply just by 5 on the top and bottom. However, and that'll give me 10a squared, but if I want to get 5a into 10a squared, I'm going to have to multiply it by 2a. So which will leave me with 5 times a plus 7 minus 3 times 2a. And that's all over going to be 10a squared. Now all I need to do is distribute 5a plus 35 minus 6a over 10a squared. And if I simplify, I'm going to be left with 35 minus a over 10a squared. And I can't really simplify this anymore, but I do have my restrictions up here and down here where a cannot equal 0. And again, remember, in order to find your restrictions, all you got to do is set your equation equal to 0 and then solve, just like in the previous lesson. All right, a couple more examples. Now we're working with addition and subtraction with a monomial and a binomial denominator. So 2x and x minus 4, those are my denominators. And let's work with one of the more complicated ones. Let's work with C. So if I have x minus 5 and x plus 1 as my denominators, then I know that my common denominator between these two are going to be x minus 5 and x plus 1. So this is just a combination of both of these as my denominator. In which case, on this side, if I want the denominator here to be x minus 5, x plus 1, all I got to do is multiply by x minus 5 on the top and bottom. Likewise, on this side, if I want the denominator to be x minus 5 times x plus 1, I'm going to have to multiply by x plus 1 on the top and the bottom. This is going to give me equivalent denominators on both sides. So I'm going to have 2x plus 1 times x plus 1 on the top, subtract x minus 4 times x minus 5. and that is all going to be over x minus 5, x plus 1. All right, just like we were doing before, once we multiply by our lowest common denominator, then we need to distribute into my brackets. So I'm going to have to FOIL both of these. If I FOIL this, it's going to leave me with 2x squared plus 2x plus another x is going to give me plus 3x plus 1. And I'm going to subtract x squared minus 5x minus 4x will give me negative 9x. Negative 4, negative 5 will give me positive 20. All over x minus 5, x plus 1. Once I've simplified this, I can get rid of these brackets, and so in getting rid of those brackets, 3x plus 1 minus x squared positive 9x negative 20 over my denominator. That'll cancel out. It'll leave me with x squared. So gathering the like terms, x squared 3x 9x is 12x plus 12x, positive 1, negative 20, negative 19 over x minus 5, x plus 1, and I have, or how do I, x plus 1, good. And so that is going to leave me with my common factors my restrictions, x cannot equal 5 and negative 1. And the last one is essentially the same thing. The only difference is my lowest common denominator is going to be made up of 3 terms.